Assalamualaikum and good evening. My name is Nur Amalin Shamina binti Saifuna, and today I will be presenting my FYP1 proposal with the title Nozzle and Bucket Rocket Using Recycled Aluminium. Recycling is the process of transforming waste resources into new materials and objects. A material's recyclability is determined by its ability to regain the properties it had in its original state. Recycling aluminium have the benefit of it can conserve natural resources, reduce demand for raw material, cut climate changing carbon emission, and also save energy as it uses 95% less than making it from the scratch. So these factors prompted this project to take the lead in the aerospace industry. And this project will focus on the concept of recycling in the aerospace industry by using used beverage cans or aluminium can. The recycled aluminum from used beverage can will be processed into a compatible aluminum alloy for the nozzle and bucket. It will undergo 3 types of testing in order to find the right aluminum alloy. This study will be a significant endeavor for the aerospace industry in finding a more sustainable material for rocket parts and also reducing production costs. Metals is one of the elements that is widely used in aerospace industry, which is a non-renewable source. Non-renewable metal, which include copper, tin, lead, aluminium, gold, silver, and other elements. Steel is also manufactured from a non-renewable source, which is iron. Over time, metal demand will be increased and finished as they are one of non-renewable resources. Used beverage cans is a type of aluminium scrap that can be recycled with the whole recycle loop of its original product. It is first developed in America and now is used in the worldwide. With this, we want to use the same concept for our project. The challenge of this project is in finding the right mixture of elements in order to produce a new aluminum alloy using recycled aluminum that is compatible with the current material. Recycling of secondary aluminum, which is from the scrap of end product life, is claimed to save resources, decrease the need for landfill spaces, and in case of non-renewable resources such as metal, it prolongs the necessary period to deplete them. From the picture attached, we can see that rocket engine or rocket motor is one of the propulsion system that exists in a rocket parts. It comprises of 4 parts, which is fuel tank and pump, missing chamber and combustion chamber, nozzle and cooling pipes. The development of the new material of aluminum alloy used for nozzle and bulkhead will be the focus of this project. Nozzle is a device that accelerates hot exhaust through the combustion reaction of fuel and propellant to create thrust in accordance with Newton's law of motion, which states that for every action in nature, there is an equal and opposite response. Common type of rocket nozzle is the convergent divergent or called as de Laval nozzle. The nozzle generating thrust of solid propellant rockets in particular is exposed to a high temperature and high pressure environment with erosion caused by combustion gas. When erosion develops on the rocket nozzle throat, it has a significant impact on flight performance, such as reaching distance and flying speed. Therefore, the material used for rocket nozzle is crucial in helping the propulsion of a rocket. Bulkhead is used for the rocket payload base. It prevents the flow of air through the tube, shielding the delicate payload from the heat of the ejection charge. The tube bulkhead are made to fit the inner diameter of the tube, while the coupler bulkhead are made to fit the inner diameter of the coupler. It can be both used at the same time or used separately. The design members of rocket team from the University of Akron made the final design use 4 aluminum bulkhead to support the recovery system as well as the motor. Polycarbonate bulkhead were used to support the electronic base and connect the coupler. The polycarbonate's lightweight characteristic will provide the rocket design more flexibility and a reasonable cost per unit. This piece is uncomplicated. Recycled aluminium used 95% less energy than making it from scratch. Results of an experiment of recycling aluminium cans done by Department of Industrial Engineering of Catholic University along with other Department of Engineering and Technology found it two crucial points, which is aluminium loss or low aluminum yield and low recycling yield. The tactics of increasing recycling yield ranging from 4% to 5% is by adding rosin flux, decoating can prior melting, and also create approach of reducing time cans exposed to furnace atmosphere during melting. The resulted chemical composition of this experiment become the guide for this project, where comparisons are made with the recycled aluminium of this project. The problem statement of this project is that the right chemical composition could not be found to make a new aluminum alloy that is suitable for nozzles and bulkheads from recycled aluminum. The recycled aluminum will result in a decreased aluminum composition and an increase in the composition of other elements such as magnesium, manganese, and iron. So, from the problem statement that we get, we found the objective of our project, which is first to analyze the chemical composition of recycled aluminium to produce a compatible and accurate amount of a mixture of element for new produced aluminum alloy, and also two is to determine melting temperature and strength of aluminum alloy so that the produced aluminum alloy made from the right composition of aluminum alloy will be tested and obtained. The scope of this project is that it will focus to create a new aluminum alloy using recycled aluminum into nozzle and bucket for rocket. And three tests will be performed, which is the chemical composition test, melting temperature test, and also strength test. The limitation of this project is that the experiment will take some time as foundry process of recycled aluminium is a lengthy procedure. This project requires the recycled aluminium and also the new aluminium alloy produced with a single furnace. The project's time frames must be carefully managed. For the methodology of this project, we will first look into the flow chart, which is first we start with collecting the used beverage cans or UBC, and then we decode the UBC. After that, we will separate it in three parts, which is the lid, body, and also the whole can. And this is as to decide which part we will use to make a new aluminium alloy. And then after that, we will undergo foundry process for the recycled aluminium and test for the chemical composition for the deciding part. And also if we obtain the right mixture element, we will continue with foundry process of aluminium alloy with the right mixture element, and then we will test the aluminium alloy, and after that we will obtain our objective. From the flow chart, the first three steps is the specimen preparation of this project, which is first the decoating of used beverage can or UBC. It is to reduce the metal loss and improve the scrap value. Can body and lids are separated after decoating. Can's body were prepared into thin product strips and little pieces to speed up the melting process by shortening the contact time of can's body and furnace atmosphere. And also for foundry process, we will use compact crucible melting furnace at 750 degrees Celsius, and the molten aluminum was then poured into a cylinder-shaped open mold and allowed to cool. After that, we will remove from the mold after it hardened. For the first stage, we will only test the recycled aluminum of different parts, which is lid, body, and whole can. Here's shown the specimen preparation that were done, which is the decoating of UBC, the separated leads of UBC and thin strips and little pieces of the body can, and also the cylinder shape open mold and the compact crucible melting furnace. After that, specimen testing will be done, which is the three tests that we will do to obtain all the objectives of our project, which is the chemical composition testing with using arc spark optical emission spectrometer, and then melting temperature test using the differential scanning calorimeter, DSC, and strength test using the compressive strength test. The expected result of this project is taken from the literature review that have been done, where it shows the chemical composition of recycled aluminium in their experiment, and this will be the guide for this project. We could see that there is an increment in aluminium composition while there is a slight increase and decreasing in the other element composition. The preliminary results of this project is that we will compare the chemical composition of recycled aluminium of our project with the past research paper in order to find the right mixture element of making a new aluminium alloy. After that, a specimen testing will be done on the specimen and preliminary results will be obtained. However, for FYP1, I could not done this part as the apparatus, which is crucible, is broken. Therefore, this part will be continued in FYP2. Now, so after that, we will be testing for the melting temperature test and also the compressive strength test for this project. And with that, we will obtain the objectives of this project. And then that's all for my FYP1 proposal presentation. With that, thank you.